Hello students, welcome to the new lecture session. Myself, Shankho host, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Sood Degree Engineering College under the JIS group. Today we'll discuss on the second part of the engine, which is taken from the module number 1, that is engine principle and the fundamentals. In the previous class, we introduced the engine and study the history of the engine development. Then we can understand the classification of the heat engine, and after that we learn about the external combustion engine, its working principle and the application. Now today we'll continue this class. So students, let's start the today's class. This is the engine part 2. So as I discussed in the previous class, the engine has only two types. One is external combustion engine, another is internal combustion engine. The internal combustion engine is known as the IC engine. In this engine, the combustion of air and the fuel take place inside the cylinder, and that are used as the direct motive power. Just because of here combustion is taken place inside the combustion chamber, that is why the engine is known as the internal combustion engine or the IC engine. The examples are the gasoline engine, diesel engine, gas turbine engine and the rocket propulsion system. So these types engines, in these cases the engines are used as a IC engine. Here you can see the working principle of the animation of the external or internal combustion engine. Here air and fuel mixture is entered this air inlet. This one is the air filter. From here air is entered here. This is the carburetor. From there fuel is entered here. So here air fuel mixture. So in this way the air fuel mixture is entered into the inlet manifold with the help of inlet valve. When it is open with the help of the cam. When it is open, the fuel is entered the combustion chamber and piston moves to the downward. And when after that piston moves to the forward, upward, the spark plug is produced spark, and due to this spark plug is produced spark, and due to the spark the air fuel mixture is sorry, the air fuel mixture is burned, combust, and after the combustion the exhaust gases, those are period of the combustion, it is out from the combustion chamber with the help of this exhaust valve when it is open, and then it passes through the environment with the help of the exhaust manifold and the silencer. So basically this is the animation of the internal combustion engine. Now coming to the application of the IC engine. Basically, because of the gasoline, four type of IC engines: the gasoline engine, gas engine, diesel engine, the gas turbine. But the gasoline engine is used in automobile, marine, aircraft. The gas engine is used in the industrial power. Diesel engine is used automotive, railway, power and the marine. and gas turbine is used for power, aircraft, industry and the mining. So these are the application of the IC engines. Now coming to the classifications of the IC engine. Now discuss the classification of the IC engine. The IC engine or the internal combustion engines are usually classified on the basis of thermodynamic cycle of operation. So students, the IC engine. So students, the IC engine are usually classified. The IC engine are usually classified on the basis of the thermodynamic cycle of operation, types of fuel used, methods of charging the cylinder, type of ignition, types of cooling and the cylinder arrangement, etc. So the various way, according to the various way, the engine can be classified. So there are what are the various ways? The various ways are, first one is cycle of operation, that is the thermodynamic cycle. Number 2, number of stroke. Number 3, the method of the charging. And number 4, the method of the ignition. Number 5, types of cooling. Number 6, cylinder arrangement. So then let's start the cycle of operation. The engine can classify according to the thermodynamic cycle of operation. That's are two types. One is Otto cycle, another is a diesel cycle. In both cases, you can see this, both the cycle, Otto cycle and the diesel cycle, both cases we draw a graph with the help of P and V, where P means pressure and V means volume. When piston moves from when the piston starts to move or the suction is completed, after that the first fourth step is occurred in this way. The one is isentropic. This is a reverse isentropic, where the input, working input, then the combustion input, then is heat. After that sorry, after that then 3 to 4 is the reverse isentropic, where the work done output, and 4 to 1 is heat rejected. So in this way, first one is work done, work, input work, then heat entered, and then work output, and then heat rejected. So in this way, these are the 4 steps where for when it moves from 1 to 2, so it varies from volume 1 to 2 with the help of P1 to P2. Then it is a constant volume when it moves from 2 to 3. Then during that time the pressure is increased from P2 to P3. So at 3 point the pressure is at point 3 there is a high pressure. Then it get, and then after that it reduces the pressure from 3 to 4. And then after the when getting the 4 P4, so the 4 to 1 is again decrease the pressure at a constant volume. So basically in this way the cycle of the cycle, which is known as this Otto cycle. Basically this is used in a petrol engine. Then comes the diesel engine cycle, where from 1 to 2, where pressure varies from P1 to P2. Then it moves from 2 to 3, where pressure is constant, that is P2, and the volume is vary from V2 to V3. After the getting the V reach the point 3, then 3 to 4 pressure is start to reduce, where pressure is coming from T2 to P4, and after that getting the P4, the volume at a constant volume pressure is reduced again from P4 to P1. So these are the cycle of the diesel cycle. The basic difference in between these at the 2 to 3 process, from 2 to 3 process, where it is entered third. So that during that time in the Otto cycle, this is a constant volume, or during the constant volume, heat addition is at a constant volume. In case of diesel, it is that is 2 to 3, that is the constant pressure where heat is added. So these are the basic difference in this. So according to this difference, the engine is two types, that is Otto cycle and diesel cycle, according to the cycle of the operation. Next is number of stroke. Basically, engine can divide into two codes. Those are 4-stroke engine and the 2-stroke. 4-stroke means the engine has 4-stroke. That is the suction stroke, compression stroke, power stroke, and the exhaust stroke. First one is suction, then compression, then power, then the exhaust. As you can see in this picture, then here piston moves to downwards. That means that it is the intake stroke. After it is reached at the lowest portion, it piston tends to move upward. This is the compression stroke. In time that both the valves are closed. After when it is reached at the top portion, the spark plug is ready. Spark plug is ready to spark, and then the piston moves to the downward. So this is the power stroke. And after that power stroke, the last one is piston moves again to the towards. This is the exhaust stroke. So these are the 4 stroke, which is known as the 4. This is the 4-stroke. 4-stroke, where they are shown in the cylinder. And so according to this, the engine can divide in the 4-stroke engine. And there another is 2-stroke, that is compression stroke and the power stroke, where compression is occurred and this is the exhaust is occurred. So here is the compression stroke, the picture of compression stroke. Compression stroke, when piston moves downward, the air fuel mixture is passed through this port to the combustion chamber, and after the power it is moved towards is compressed and it is exhaust, and after that it start the power stroke, and when it moves to the downwards, then the exhaust gases comes out. So these are this is known as a 2-stroke. So basically according to this stroke, the engine is divided into two, that is the 4-stroke engine and the 2-stroke engine. Next is types of fuel. There are various kinds of fuel is used in the IC engine. One, that is liquid fuel. Engine using the volatile liquid fuel. For an example, gasoline, alcohol, kerosene, benzene, etc. The fuel is generally mixed. The fuel is generally mixed with the air to form a homogeneous charge in a carburetor which is outside the cylinder and drawn into the combustion chamber of the cylinder in its suction stroke. The charge is ignited. Near the end of the compression stroke. The charge is ignited near the compression stroke. by the by the externally applied spark, and therefore these engines are called as the spark ignition engine. Next is gaseous fuel. When engine using the gaseous fuels like compressed natural gas or CNG, liquefied petroleum gas or LPG, blast furnace gas and the biogas. The gaseous fuels are comparatively better compared to liquid fuel because of the reduced ignition delay. So gaseous fuels are comparatively better as compared to the liquid fuel, better compared to the liquid fuel because of the it reduces the ignition delay. The gas is mixed, then the gas is mixed with air and the mixture is introduced and mixture and the gas is mixed with the air and the mixture is introduced into the cylinder during the suction process. Working on these types of engine is similar to that of the engine using the volatile liquid fuel or SI engine, SI gas engine. Next is solid fuel. Engine using solid fuels like charcoal, powder coal, etc. The solid fuels are generally converted into gaseous fuel. Solid fuel is converted into the gaseous fuel outside the engine in a separate gas producer, and then the engine work as a gas engine. Next is engines using the viscous liquid fuel like heavy and light diesel oil. The fuel which is generally introduced, the fuel is generally introduced into the cylinder in the form of a minute droplets by a fuel injection system near the end of the compression process. The combustion of the fuel takes place due to its combustion into the contact with the high temperature compressed air in the cylinder. Combustion of the fuel takes place due to its coming into contact with the high temperature and compress the air in the cylinder, and therefore these engines are called as the CI or the compression ignition engines. Then is engine using the two fuels, a biofuel, a gaseous fuel or a highly volatile liquid. A gaseous fuel or a highly volatile liquid is supplied along with air during the suction stroke or during the initial part of the compression through a gas valve in the cylinder head, and the other fuel is injected into the combustion space near the end of the compression tube. These are called as the dual fuel engine. So according to this fuel is classified. Number first one is liquid fuel, second one is gaseous fuel, third one is solid fuel, fourth one is viscous fuel, and fifth one is dual fuel. So according to the fuel, the engine has classified into the 5 way. Next is method of charging. According to the method of charging, the engine are classified in two ways. One is a naturally aspirated engine. Number two, is supercharged engine. Naturally aspirated engine means the admission air or fuel air mixture at near the atmospheric pressure. Yes. When air is intake into the combustion chamber, the air and the fuel air near mixture are at near to the atomic pressure. So there are no extra pressure is added here. So that is the naturally aspirated engine. Second one is supercharged engine. Next is supercharged engine. There is the admission of air or fuel air mixture. Admission of air and the fuel air mixture under the pressure. That means when air and air fuel mixture is introduced into the suction stroke, this that time they are added some extra pressure with the atmospheric pressure. That is why the engine is known as the supercharged engine. So according to the method of charging, the engine can be classified in this way. Number one is naturally aspirated engine, and number two is supercharged engine. Next is types of ignition. Spark ignition engine require the spark ignition engine or the SI engine require an external source of energy. It require external source of energy for the initiation of the spark, and thereby the the combustion thereby the combustion process. So SI engine require an external source of energy for the initiation of spark during the combustion process. So a high voltage spark is made to jump across the spark plug electrode in order to produce the required high voltage. There are two types of ignition system which are normally used. They are number one is battery ignition, second one is the magneto ignition system. They drive their name based on the whether a battery or a magneto is used as the primary source of energy for the producing the spark. In the case of SI engine, there is no need for an external means to produce the ignition. Because of high compression ratio employed, the resulting temperature at the end of the compression process, is high enough to self-ignite the fuel when it is injected. So however, the fuel should be atomized into the very fine particle for this purpose of the fuel ignition system. So student, just because of CI engine, no need to require an extra ignition power. So only SI engine is required an extra ignition power. So for the extra ignition system, we use the battery ignition system or the magneto ignition system for the starting the initial spark to produce a spark. So according to this, the engine can be divided into two ways. That is battery ignition system engine and is magneto ignition system engine. Next is the types of cooling. Cooling is very essential for the satisfactory running of the engine. So there are the two types of cooling system used in the engine. One is air cooled engine, another is water cooled. When engine is run or combustion is occurred inside the engine, so the heat is generated. If 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 we cannot dissipate the heat which is generated inside the engine, then after some time the the parts of the engine should be seized. Would be would be seized. To stop this seizing the to stop or to avoid the seized of the material inside the parts of the engine, we use the cooling system. So there are two types of cooling system are used. One is air cooled engine and the other is a water cooled engine. The air cooled engine has fins which is helps to dissipate the heat from the combustion chamber, and water cooled engine, there is a water jacket, and in the water jacket the water is supplied with the regulator of the water. The heat is regulator, that water is collected the heat from the combustion chamber. So in this way the engine gets cooling down. So in this, according to the cooling type, the engine is two types. One is air cooled engine and is water cooled engine. Next is engine cylinder arrangement. Another common method of classifying the reciprocating engine is by the cylinder arrangement. The cylinder arrangement is the only application level. This is only applicable to multi-cylinder engine. Two terms used in connection with the cylinder arrangement. Two terms used in connection with the cylinder arrangement that must be defined first. That's a cylinder bank and the cylinder row. Cylinder bank means an arrangement of cylinder in which the center line of the crankshaft journal the center line of the crankshaft journal is parallel to the plane containing the center line of the engine cylinder. These are the known as a cylinder bank. So in this so student, basically in the cylinder bank arrangement, the center line of the crankshaft journal is parallel to the cylinder arrangement. When the cylinder are arranged in this way, when the cylinder is arranged in this way, that means the cylinder bank position, the engine is called as the inline engine or straight engine. When there is a large number of cylinder, the cylinders are arranged in two lines which are at an angle to each other in a V form, and that is called, engine is known as a V-shaped engine. And each line in such arrangement is called the cylinder bank. The angle between the cylinder bank is known as the bank angle. Cylinder bank are found in inline and V-shaped engine. Cylinder bank are found in inline and V-shaped engine. Some of them are single bank engine and other are multi-bank engines. Next is cylinder row, an arrangement of cylinder in which the center line of the crankshaft journal is perpendicular to the plane containing the central line of the engine cylinder. Means in the cylinder row arrangement, so in the arrangement of the cylinder row in an engine in which the central line of the crankshaft is perpendicular to the central line of the cylinder in the engine. These cylinders are actually arranged radially and are perpendicular to the center line crankshaft. These cylinders are actually arranged radially and they are perpendicular to the center line of the crankshaft. So in these types of cylinder, and cylinder radiate outward from a central crankcase like the spokes of the wheel. The radial engine was the first constructed by the C.M. Manley in the year of 1901. If the engine has more than one row, then it is called as the multi-row cylinder. Now coming to the various types of engine according to the cylinder arrangement. Here, as we can see, this is the inline engine. Means the inline engine is an engine with one cylinder bank. That is, all the cylinders are arranged linearly. And transmit power to a single crankshaft. Transmit the power to a single crankshaft. And this type is quite common. This is a quite common type with automobile engine. 4 or 6 cylinder inline engines are popular. 4 and 6 cylinder inline engines are popular in the automotive application. Next is V-shaped engine. In this engine there are two banks of cylinder inclined at an angle to each other and with one crankshaft. Most of the high power automobiles use the 8-cylinder V engine, 4 inline on each side of the V. Engines with more than 6 cylinders are generally employ this configuration. Next is U-cylinder engine. The U-type is a variation of opposed cylinder type. The variation of the opposed cylinder type arrangement. Next is X-type. X-type is the design is the variation of the V-type. It has a 4 bank of cylinder which is attached to a single crankshaft. Then coming to the H-type. The H-type is the essentially two opposed cylinder type, which is utilizing to separate but the interconnected crankshaft. Next is radial. Radial engine is one where more than 2 cylinders in each row are equally spaced around the crankshaft. The radial arrangement of cylinder is most commonly used in the conventional air-cooled aircraft engine, where 3, 5, 7 or 9 cylinders may be used in one bank and 2 to 4 banks of cylinders may be used. The odd number of cylinder is employed from the point of view of the balancing. Piston of all the cylinders are coupled to the same crankshaft. Next is opposed cylinder. Opposed cylinder engine has two cylinder bank located in the same plane on the opposite side of the crankshaft. It can be visualized as two inline arrangement at a 180-degree apart. It is inherently a well-balanced engine and has the advantage of single crankshaft. This design is used in the small aircraft. Next is opposed piston. When a single cylinder houses two pistons, each of which driving a separate crankshaft, then it is called as the opposed piston engine. The movement of the piston is synchronized by coupling the two crankshafts. Opposed piston arrangement like opposed single cylinder arrangement, and it is inherently well balanced. Further, it has the advantage of require no cylinder head, but its inherent feature. This engine usually function of the principle of the two-stroke engine. Next is the delta type. Delta type engine means that the delta type is essentially a combination of three opposed piston. Combination of the three opposed piston engine with the three crankshaft. Those are interlinked to one another. So according to this, these are the cylinder arrangement. Engine is classified according to the cylinder arrangement. That is the classification of the IC engine, where IC engine classified into two ways. One is 4-stroke engine, then is 2-stroke engine. Both are classified into two ways, SI engine and CI engine. SI engine can classify into the two, petrol engine and gas engine. Both are classified into these two, carburetor type and the injection type. Both of them are divided into these two, battery ignition and the magnetic ignition. And CI engine classified into two, that is dual fuel or the multi-fuel engine or divided chamber engine. Both are then divided into these two, pre-chamber and the swirl chamber. Both of these, pre-chamber or swirl chamber, is CI engine, and the battery ignition, the magnetic ignition of SI engine, both of them can be classified into two ways, that is the air-cooled and the water-cooled. This air-cooled and water-cooled engine can be classified into three ways, that is rotary engine, reciprocating engine and reciprocating multi-cylinder engine, single cylinder, multi-cylinder engine. The rotary engine can be classified into three ways, that is V cylinder, another is inclined cylinder, and third one is the opposed cylinder. And the reciprocating, there is two types, one is single rotor and the twin rotor. So these are the basic classification, basic types of the basic structure of the classification of the IC. So students, today we covered the classification of the IC engine. So from the next class we will continue the IC engine with its working principle. So still then, stay at home and stay safe. Thank you so much students.